Good morning, guys. Thank you so much for taking the time to watch my videos. I know sometimes it's really easy to just email me and say, I don't know what I'm doing. So I appreciate that you're starting here to learn how to do this next lesson, this next worksheet. We'll jump right in. Please get out. You'll need both your notebook and your study guide and intervention worksheet. I'm going to do a few of those problems. So the first thing I want you to do is pause this video and write this down. So this is talking about your parent function. A parent function is kind of the most general, basic, what you're going to start with. And then every other function is like that, just a little bit tweaked. So, you have your parents' genes, but they're changed just a little bit because of each one. Parent functions are the same type of thing. They're in general pretty similar, but they may have a different kind of slope. When you get to curved lines, there might be more bumps, that kind of thing. Might be shifted up, down, left, or right. So this type of graph is a line, and when we're talking about domain and range is straight up and down. So it says all real numbers for the domain because everything going up works and everything going down works. There's no point that the line wouldn't have a solution because it keeps going on forever. So pause this if you haven't already, finish writing this down, and then I'm going to keep going. So what it says is to solve this equation by graphing. So the first thing you need to do is you need to get these equations equal to 0. Once you get these equations equal to 0, you're actually going to substitute in f of x. Now, if you'll recall, quite a ways ago, we talked about how f of x is not f times x. F of x is y, basically. It's just saying the output of this is whatever we found it to be. So 3x minus 3. So all you're going to do here is replace 0 with f of x. I wonder if I could even type it in. I want you to write that in there just as a little reminder to yourself. We're going to replace 0 with f of x. Then what we're going to do is we're going to make a table, just like we did with the true, false type of thing. We're going to make a table again. Inputs and outputs. And then we're going to use our function here, this 3x minus 3. We're going to check out some x values, and then we'll be able to graph it. The easiest numbers that I find are -1 and 1. You could also do -2 and 2, whatever you want here, but I'm going to go -1, 0, and 1. So what this is going to do for us is when we plug in -1, 3x is also known as 3 times x. So in this case, it's 3 times -1. 3 times -1 is -3, minus 3 more is -6. Then we're going to do 3 times, instead of -1, this time we're going to do 0. 3 times 0 is 0, minus 3 is -3. Then we'll check out 1. 3 times 1 minus 3. 3 times 1 is 3, minus 3 is 0. Now, I have something weird happening here because I don't have -6 on my graph. So I'm actually going to go it looks like it's starting to go up here. So I'm going to add one more point just to see if I can get an easier point to graph. So we have 3 times 2, which is 6, minus 3, which is 3. So it looks like the easiest points to graph are going to be these 3 because we'll be able to find them on our graph. So let's do that right now. Whenever you graph a point, I want you to graph a line, I want you to graph at least 3 points. 3 points is what, your minimum amount that you can graph with it showing to be an actual line. If you just have 2, it's really easy to get it a little bit wonky, a little bit tweaky, and you'll see in the later chapters of Algebra 1 why that is. So the first one is 0, -3. X is 0, so I'm going to find 0 on the x-axis, and then it says -3, so I'm going to go 1, 2, 3 down. Then it says when x is 1, my y is 0. So I'm going to go 1 over and then no up or down. The next one tells me when x is 2, my y is 3. So when I go 1, 2 over, y is 3 up. So you count 1, 2, 3 up. And now you have enough lines to draw, or enough points to draw your line. And that is your problem. So on this other part, you could even write a note to yourself saying, make a table. And then what we did right here is graph the points. So those are just kind of little notes to ourselves saying what we just did. Replace 0 with f of x, make a table, and then graph the points. I'm going to show you one more example of that on the next slide. If you need to still write this down, pause this video now so that you can finish, and then I'm going to keep moving. So here's one where you actually do not have a 0 on one side, so we need to solve for a 0. I'm looking at this and I see this -2x on the right side of the equal sign, so I'm going to try to move 2x. Don't forget to always draw your little T thing. And there's something weird that actually happens with this one. In that -2x plus 2x is 0, so all we have left is 1 and a 5. I'll remind you that we've seen problems like this before, and what we call this is because 1 does not equal 5, that is not true, we would say no solution. If it was 1 equals 1, it could work, and we would say there's infinitely many solutions, but here there's no solution. If you have the next problem, you will be able to solve for x. So what you'll do is you'll move x's on the same side, and then you move the 5 over as well. You just want it to get to equal 0, and then you'll follow the steps in the last slide. If you need a reminder, you can always follow along by rewinding the video and then following it along. All right, pause this if you need to. I'm going to move forward. So we can also do this with application problems. And so I really like that with application problems, you can kind of the whole lesson on applications is helpful because this whole lesson is really, really relevant to what we do in everyday life. So maybe not Jessica recording songs important, but you could apply it to other things as well. So it gives us this function c equals 80 minus 3.22n. So it says to find the 0 of this function and describe what this means in the value of in this context. So what we're going to do is if our c equals 80 minus 3.22n, I'm going to pretend the number of songs is 0 because it says find the 0 of this function. So if n is 0, that becomes 80 minus 3.22 times 0. Which just becomes 80. So when we have 0 songs, we have 80 minutes available. So when it says to describe what this value means in this context is when Jessica hasn't downloaded anything, she has 80 minutes available on a CD, which, this may be more relevant if you're talking about an iPhone. I don't know if anybody still has an iPod, but it might apply more there at this point. I used to burn CDs with music. I don't think any of your generation has. So, if you want to cross out CD and put iPhone, there's a few other things that in your textbook they want you to do. I just want you to understand this concept right here first, and then we can move towards other parts of this later on. I'm just trying to pick the most important things here. So I want you to at least find the 0 over here. If you wanted to find the 0, so the number of songs you can fit on there, you would solve for n. You would put C equal to 0. Maybe I'll do a different color for this just so it's not confusing. You would make C 0, and then you would solve for what it is. You could add 3.22 to both sides. I'm not going to write it out only because I do not have room, but you'll say plus 3.22 on both sides, and then you get 3.22n equals 80. 3.22n is like 3.22 times n. I'm going to use my calculator to calculate that out because I can definitely not do that in my head. And this comes out to about 24.84. Can you have 0.84 of a song? Hopefully I can feel like Dora the Explorer video, but no, you can't. You can't have half of a song. So the number of songs would be about 24. We could do the max of 24 songs, which does not seem a lot, but it was a lot back in the day when we wanted to make, CD mixtapes for our friends, and we'd burn CDs to trade them. But anyways, I appreciate that you've gotten this far. Keep it up. I know distance learning is a struggle, and it's not almost anyone's favorite, so I'm really proud of you for keeping up with your work so far. If you are behind and you're catching up, thank you for working on catching up. I appreciate you taking the time to do this. Good luck with your worksheet tomorrow.